In part 2 of our series where we write complete ionic and net ionic equations, we left off with question 2. Question 2 reads, consider the following reaction occurring in aqueous solution. Write the complete ionic equation and new ionic equation for this reaction. What we have to do is look at each individual compound and break it down into its ions, except for compounds that are either liquid or precipitates. Let's start with the first compound. We have hydroiodic acid, represented by the formula Hi. This compound breaks down into two hydrogens, and hydrogen has a charge of +1. Its state should also be written plus 2 iodine ions, and that will serve as our anions here. Its state is aqueous, plus barium hydroxide. Barium has a charge of 2+, which serves as the cation of this ionic compound. There's only one barium, so we write down barium with a charge of 2+, plus 2 hydroxide ions, 2 times OH negative AQ. This yields 2 water molecules, and I won't break this down because it's not aqueous. We have 2H2O at a state of L for liquid, plus barium iodide. Barium AQ plus iodine with a charge of 1- times 2 because of that 2 subscript. Now we have to eliminate our spectator ions. Notice that we have 2 times iodine ions on the left side and 2 on the right side. Those cancel out. The barium ions cancel out, leaving us with what I'm highlighting. So for our net ionic equation, we'll write exactly what's highlighted. This gives us 2 hydrogen plus ions plus 2 hydroxide ions, yielding 2 water molecules. That's the answer for question number 2. Let's move on to question number 3. In question number 3, they're expecting us to write the complete ionic and net ionic equation for the following reaction occurring in aqueous solution. We'll be following the exact same steps as in questions 1 and 2. The only compound here that doesn't dissociate is this compound circled. That's our solid. Let's start with our first compound. We have AgNO3, in other words, silver nitrate. The ion silver here has a charge of 1+, so I'll write down Ag 1+ AQ. And notice that we have a coefficient in front of this compound, so I'll multiply this by 2 plus 2 nitrate ions. This serves as our anion, this is our cation, also AQ, plus Mg, which has a charge of 2+, our cation, and chlorine. Chloride is represented by Cl, 1-, and there are 2 of them, so you place a 2 at the front. This produces our precipitate, which we won't break down. We'll write down 2AgCl, and that's in its solid state, plus Mg, 2+, AQ, plus our final anion, NO3, multiplied by 2 because of that 2 on the outside, with a charge of 1-. Now we eliminate our spectator ions. This cancels out with this cancels out with this, and we're left with what's highlighted. That will serve as our net ionic equation. 2Ag 1+ plus 2Cl 1- produces 2AgCl. Now make sure that the left and the right side are balanced, because if they're not balanced, it means you've done something wrong. 2 Ags, 2 Cls. And there you have it. That is how to write complete ionic and net ionic equations.